This conference will now be recorded.
Good morning, good afternoon, good evening. Welcome, everybody. My name is Christine Perret. I'm one of the co-chairs of the Points of Interest Standard Working Group, and I'm going to be your host today. Welcome, everybody. I appreciate people taking the time to attend this briefing, and I look forward to the conversations that follow and our exploring this new specification or draft specification with you. So over the next hour, we're going to hear about the conceptual model, some of the implementation experience from Chuck, and then we're going to have 3 of our working group members and other people who have contributed heavily presenting their use cases. And then we'll have a few minutes at the end when I expect that we'll have some discussion with you and look forward to hearing your questions. Because we want to accommodate people in the, let's just say the Eastern time zones in Asia, we are going to have a second one of these briefings, and that will be hosted by Matt Purse, the other co-chair of this SWIG. So now I'll go ahead and remind you or share with you why we're having this briefing and what our goals are. So we've been working for about 1.5 years, I believe, to update and to develop further a points of interest standard. This work started over a decade ago in the W3C, and we picked it up again. I think it was the spring of 2021. Might be 2020, I'm not sure. But we've really developed a completely different approach, and we want to share with you our draft specification in order to better understand if it meets the needs of the community. And so that's the broader discussion and engagement that we're seeking. And yeah, hopefully we will be able to get your feedback, not only in this call, but also on GitHub or through emails on our working group mailing list. So that's just the brief introduction. And now I'd like to ask Chuck Hazel, who has been our architect and an extremely active member of the Standards Working Group, to go ahead and unmute and begin the presentation about the conceptual model. Welcome, Chuck.
Thank you, Christine. Next slide. So let's start out with the understanding that this POI standard is a conceptual model. If you haven't caught what's going on in OGC recently, we found that the proliferation of different encoding formats make it difficult to create a single standard for like a POI. So what we've done in many cases is we've created a conceptual model, which is a platform independent standard, which is then implemented through a set of implementation specifications. For POI, this is the conceptual model, the platform independent standard, which will then be later specialized for different technologies by an implementation specification. So also following the pattern that's being used across the OGC, the conceptual model is captured using UML. So there is a underlying UML model to this standard. And what you have in the standard document is some image captures out of the UML model, as well as a data dictionary that ultimately will be generated directly from the UML model. Right now, it is still a handcrafted product, but our goal is to have a UML model to generate the content of the standard from the UML model, and that effectively makes the model normative, and the standard itself is a representation of that normative model. Everyone confused yet? Good. Some fundamental principles going into this is that a POI is not a data set, it's a feature type. A POI has to integrate with an existing data set, which means it has to be able to adapt to any feature model that you're working with. So therefore, the POI conceptual model has been designed to be very adaptable, very flexible. Second of all, don't reinvent. If there's already an existing class, if the concept is already defined somewhere, reuse it. Don't create a new one which is almost but not quite the same. And once again, keep it flexible. One thing we can do if we do this right is we basically can use the UML model and the standard to define the logical structure of a POI, but the actual meaning, the semantics, can be defined externally. And we use code lists to do that. There are other ways of doing it too. But the nice thing about this is that I don't have a dozen different copies of the same data structure. Each one means something different because I gave it a different name. I can define that data structure once. I can encode the processing for that data structure once, but I pull the meaning of that data structure by some sort of tag or identifier. Okay, next slide. The relevant standards we're building on, 19103 is the underlying data types that are used across all of the supposed to be used across all of the OGC standards. I'm not going to argue that it necessarily is. ISO 19107 is the ISO geometry model. ISO 19109 is the feature model. If you've been looking into OGC at all, you know that our fundamental concept is the feature. A feature is a real-world object. Features have geometry. So these three standards, 103, 107, and 109, pretty much lay out the whole foundations for OGC data, for the OGC data architecture. We brought in ISO 19115 because that is metadata. There's a rich collection of data types in there, which are very suitable to be reused. And we also pulled some stuff out of CityGML 3.0, which has some extensions on the feature model, which are quite applicable to what we're doing here. So when you look at the POI model, you'll find very little in the POI standard, which is actually new. Most of it is reused. Here we have a brief overview of the ISO general feature model, like ISO 19109. Once again, a POI is a feature. As such, it inherits all of the properties of a feature, including the ability of a POI to be a collection of POIs. It also means that we're reusing the whole concept of attributes, and the properties of features are actually reused in POIs. So maximum reuse here. Next slide. Here's the ISO geometry model. This is the geometry model we're using for POIs. It's taken straight out of ISO 19107. What we have done is we've restricted the ISO geometry model to only include points, line strings, and polygons. And that is something that we need to validate. That restriction, is that restriction sufficient, or do we need to make the geometry a little bit more complex? The problem is, the more complex the geometry, the harder it is to implement a POI. The less likely it is that the POI will actually serve the purpose of providing a simplified representation of a complex feature. But this is our starting point. We think this is sufficient. We like broader feedback than just a swig. And next slide. So this is the overall POI model. The bits in green are what's actually in the POI model. The rest of it is what some of the stuff carried over from the ISO standards. We are only adding 1 to 5 new classes. AbstractFeature is pulled out of CityGML. It does a better job of articulating what your basic feature model is. AbstractFeatureWithLifespan gives some gives some temporal properties to the abstract feature, when it was created, when it's valid, things like that. AbstractPOI, which is our abstract definition of a POI. This is a POI. This class is a POI. And then POI Properties is how we map properties from the feature data, the data set that's being described, into the POI itself. So what this means is that we haven't actually defined a fixed static model for POIs. We have defined a core model for POIs and a mechanism to bring additional properties into the POI as needed by your use case and by the data set that it's supporting. And finally, an important link is feature of interest. This was borrowed from a number of different standards. You see this a lot in OGC. What this is a URL to the feature in the data set that this POI is describing. So this is how we associate a POI with a feature in the data set. And this is very important because as you use a POI, you probably will want to drill down from the POI, which is a simplified representation, to the actual data underlying it. Questions at this point? Next slide. So what I showed you was the high-level view, the pretty pictures. What we're getting into now is a data dictionary. This is actually drilling down into what each one of these POI classes contain. And this is pretty much exactly what's in the specification right now. So AbstractFeature. AbstractFeature is the superclass of all the POI model. This is taken out of City GML and is being reused in POI. It's got a description, feature ID. Feature ID is mandatory. All features have a feature ID. This is fundamental. Description is optional. It's useful but not required. An identifier is optional. It's useful but not required. And note that the identifier is a scoped name, which means it is not just an identifier, but also the scope or the context within which that identifier is defined. So that allows me to use any type of identifier as long as it's under some sort of controlled vocabulary, so I can map into that definition for what that identifier actually means or what the rules governing that identifier might be. Excuse me. And then a name, which is simply a generic name, basically a text string. That is also optional, and I can give it multiple names. So I can give an abstract feature a dozen different names. They're all valid. They really don't carry all that much baggage with them. Next slide. So abstract feature with a lifespan is an extension of the abstract feature. It is a subclass. This was also reused out of CityGML 3.0. And what this does is it adds 4 date time properties to the feature, abstract feature. When was it created? When was it deleted or terminated? What's it valid from? When does it become valid? When does it stop becoming valid? So this allows a feature a POI to persist even when it's no longer valid. It also allows you to go back and see when the feature was created and when it was deleted. Terminated is probably a better term because it may not be deleted, but it may no longer be considered part of the data set. So this gives us some basic management data for the POI. Now keep in mind these properties describe the POI, not the feature the POI is describing. Next slide. Abstract POI, once again, this is where we have the stuff which is specific to a POI. And also keep in mind these are properties of the POI itself. These are not described, well, except for one. They don't actually describe the resources being described. There we go. So we have the contact information. And thing about the reason we use CI responsibility is because CI responsibility includes a field which is the role of that contact. So I can have multiple instances of contact information, each one with a different role, which gives me a lot of flexibility of saying, here's the creator, here's the publisher, here's who you go to if you have a problem with it, I can do 100 different contact informations, each one with a distinct role, and I can go quickly find which contact information is applicable to the problem I want to solve. Has feature of interest. We touched on this before. This is a URI to the feature in the data set that this POI describes. Has metadata. allows me to take a separate metadata file of some sort, undefined, we don't care what it is, but it is associated with the POI through URI. URI, URL, same thing. Has property. This is where the POI properties plug in. So the POI properties are representations of properties of the feature or features being described. By representation, I mean a simplified, easily consumed by a human user version of a more complex concept, which is in the feature model itself, in the data set itself. This is where we use the POI property class, which we'll get to in a few minutes. We have keywords, MD keywords out of 19115, like the CI responsibility up above. This associates a scope and a meaning to each keyword, so it gives me a common piece of syntax I can use over and over and over again, a common data structure. So I can put in the keyword, I can tell you where that keyword is defined, I can tell you what domain, what scope that keyword exists in, so I can put basically anything that looks like a keyword I can put in. MD constraints are legal and security constraints. Once again, taken out of 19115. And symbology. Clearly, we want to be able to support symbology if there's a symbology architecture that goes with a data set. We don't know what it is. I don't think we really can define it in this standard, but we provide a URI which will point to the symbology information, which arguably should be associated with the data set, not with the POI. And this is the key of the whole, go back up one. This is really the center of the whole standard, is this class right here. So are any questions on this? There was a question. All of they're all optional. The only one which is two that are mandatory is there has to be at least one contact info, and there has to be at least one feature of interest. Beyond that, if you don't want any properties, that's fine. If you don't want keywords, that's fine. We don't put in any constraints except for those that absolutely have to be there. Any other questions? Let me check the chat just for a moment. Okay, geometry is actually technically optional because you can have a feature that does not have geometry. And arguably you could have a POI that does not have geometry. We kind of take the philosophy that unless it absolutely has to be mandatory, we leave it optional. And when you get right down to it, an awful lot of this is not really essential in every case. So you could have, on the flip side is I can have a valid POI which has very little content in it. On the flip side, I'm not making you populate something which is irrelevant to the use case you're trying to, or the problem you're trying to solve. So it's kind of a trade-off between flexibility versus conformance requirements. We've gone more with the flexibility side because there's so many different ways POIs are used, so many different data sets that are used with. We felt that minimizing the requirements, the required capabilities, minimizing the mandatory elements would make a much more usable standard, even though it now becomes much harder to validate. Any other questions? Okay, POI property. POI property is how we map a property from the data set, from a feature in the data set into the POI. That is, how do we create in most cases, it'll be a simplified representation of a more complex property, more complex attribute of a feature that's being described. It's built on top of the attribute type class, which is defined in 19109, I'm sorry. And all we really do is we add a value to it. So the attribute class from the ISO standard says we need to define the cardinality, how many there are. We need to define the value domain, and we need to define the value type. Okay. the added value to that, and I have everything I need to describe the the nature of the property. I have a name because I've given it a name when I create the property, the POI property, and I have the actual value. So this looks to be sufficient, and it allows us to basically map any attribute, any property of any feature into a POI, and however you want to do it. So that's it for POI property. And feature of interest. Feature of interest is basically a placeholder for any feature in the data set. So it allows us to have a target for the URI, which points back to the feature or features that this POI is representing. It has no. It's basically it's a placeholder. It's a proxy for an actual implemented feature. So it has no attributes. Next slide. Let's see. I added CI date because it's an example of a code list. CI date comes out of ISO 19115, and it has two attributes. One is the date time. That's a mandatory attribute. What is the day? What is the time? Very straightforward. But it also has a COI date type. That should be the date time. That's a typo. I have to fix that. No, maybe not. Okay. Anyway, the date type code is a registered set of values for what that date time could represent. And there's a copy that's maintained by ISO. There are other organizations which have actually extended this code list. But because it's a code list, you can add it's being managed by somebody. OGC manages a set of code lists for the OGC standards. And if you identify new valid values, it's basically an extendable enumeration. It's a set of controlled values which can be used to describe what this date time represents, but there's a management structure which allows you to add new values to that code list if you have a new set of requirements arrive. So essentially, it's an extendable enumeration, which is a very powerful concept. It also allows us to define CI date once, to have one set of software for processing CI date, but have the semantics, the meaning of CI date, easily changed. This is a pattern that is commonly used within the ISO standards, and it's one I would strongly recommend that we adopt in some way, shape, or form for POI because of the tremendous flexibility it allows us to have. Any questions here? Okay. So what you've seen so far is a high-level overview of the POI model. This is a conceptual model. Now, the question comes, how real is this? Is it actually implementable? So to complement the conceptual model, we did a little bit of a hand jamming of I just drew a blank. Of a JSON implementation. Next slide. So what we did was we created a GeoJSON schema for POI. Then we collected examples of existing POIs, tried to encode those samples using the GeoJSON POI schema, and we tried to capture all the issues and the problems that came up in going through that exercise. So this is what we did. Next slide. So the GeoJSON schema for POI was pulled down from the GeoJSON website. We removed all the geometries except for point, line, string, and polygon. We added properties to represent the POI classes. And then we added a JSON objects from ISO 19115. Now, the reason for doing the JSON objects is that there are a lot of objects in 19115 that are good candidates for reuse in a GeoJSON POI schema. So we threw them into the GeoJSON schema in order to make them readily accessible to implementers for reuse within their own specialization of the GeoJSON schema. Does that make any sense? Okay. Questions at this point? So this JSON schema is on the GitHub repository under examples, GeoJSON schema. And we've used it, at least members of the SWIG have used it, and it's publicly accessible. If you want to beat on it, tell us what's wrong with it, feel free to do so. Next slide. So the requirements for a POI, this is kind of walking through the requirements from the standards, the conceptual standard, and this is addressing how they're implemented through the GeoJSON encoding. So first of all is the requirement that it be a subset, that the POI is a subclass of FeatureOfInterest, and we borrowed the encodings from CDGML 3.0. POI shall be comply with requirements for POI contact info. Remember, contact info was a required element of POI. So we borrowed the CEI responsibility type from the, basically we converted the XML encoding in ISO 19139, which is the XML encoding of ISO 19115, and returned it into JSON and included it in here. So we have a requirement that it has to conform with it has to have a feature of interest. It's a URI that's easy to do in JSON. Metadata, URI, easy to do in JSON. POI property, we talked about POI property, I think, in the next slide. We have keywords. Once again, we converted the XML encoding in 19139. Rights, we converted the encoding in 19139, and symbology is a URI. So this is the approach we took to taking the conceptual model and instantiating it as a GeoJSON schema. Any questions? Okay. POI properties, it should have 0 or more value attributes, convey semantics by the value attribute. Okay, we'll go through all this. This gets a little bit more complicated because how you actually implement the attribute type is very dependent upon the technology you're using. A lot of what's called for in the attribute type is actually represented in the syntax of the encoding. So a POI property, JSON object definition includes the cardinality, it includes the data type. So I think we've actually met the requirements for POI property in the way we've implemented POI property in the GeoJSON schema for POI. But there's a little bit of judgment involved here because it's not a straight A equals B, B equals C, C equals D translation. It's kind of A goes to here, B goes over there, C goes over here, and you've got to do that mapping of how each property, each requirement is actually represented in the technology, the target technology. Not a straightforward mapping sometimes. So one of the things that comes out of this is whether this is actually the most effective and efficient way of capturing POI properties. And for that, we need implementation experience, which is one reason why we're here today. And next slide. So I'm going to wrap it up with a couple questions for the community, largely driven by our GeoJSON experience. Do we need to add any more standard properties to the POI? Remember, POI has a fairly minimum set of standard properties. These are properties which are expected to be probably common across all POIs. Are there more that need to be there? Are there other ones that have to be there and need to be mandatory? What's your opinion? What do you think? What does your implementation experience tell you? Does a conceptual model capture everything we need? It was designed to be very modular, very adaptable, easily adapted for different data models, different data sets. Is it sufficient? Is it too adaptable? Does it not have enough specificity? Is it too rigid? What do you think? And can we actually create conforming coding specifications from the conceptual model? Our hand exercise suggests that we can, but some of you, I suspect, have actually worked with some of the implementation specification initiatives where they generate the implementation specification from, say you work with shape change, generating it from the UML model. Can we do that with what we have here, or do we have to make more adjustments? So basically consider this a beta. Look at it, tell us what's wrong with it, tell us what's right with it, and kind of like to make sure that when it goes out for public review, it is a 99% correct standard. And that's all I have.
Thank you, Chuck. Yeah, that's perfect. What I'd like to do is to go ahead and have those 3 use cases illustrated, and then we'll have some time left at the end for discussion and questions. And be fine if anybody has questions during the presentations to put them in the chat. So now I'd like to go ahead and ask Cohen Debates to unmute and present to us what you've been working on.
Okay, hello. So I'm Koen and I work at the government of Flanders. And in Flanders, we have a lot of institutions and agencies that have data with address information or some geographic information. And they need that data for their internal business processes. But some of that data is also interesting to make publicly available to other agencies or civilians. And they want to share this data on a geo portal. And that's where my use case comes in. Next slide, please. And here you can see the geo portal we have in Flanders. And in the next slide, you will see one of the map layers. In this case, it's a map layer of POIs representing hotels. And the hotels, that's data that comes from the tourist agency in Flanders. They have their own data model, and we create POIs that can be represented here in this geo portal. And in the next slide, you'll see that we also wanted to make the POIs searchable. So if you enter a keyword or address information or something that is in the description of the POI, then it should be findable. And once you have found your POI, and in the next slide, you can see that you can ask for the detailed information. So this is what you get. You get the name, contact information, and links to additional, more detailed information about the feature that the POI is representing. So in the next slide, you can see on the left side, you see the source data model of, or the feature data. In this case, it's a hotel, but it could also be, for example, a hospital or maybe a library. Those are all maintained by different agencies, different data models. And what we do is we map it and transform it into a POI data model that we have in Flanders. But of course, it should be a lot better if we could use an OGC standard data model. So in the next slide, you can see the JSON file. So here I have tried to map the model that we use now to the new draft model that is presented here today. So first we have some descriptive attributes. As you can see here, So a short description and a name and additional information. For example, here an alternative name is put into the keywords. And in the next slide, you'll see that we also have some classification types. We have 3 levels of classification, and these are also modeled as keywords. And those keywords are represented in a code list that is available or should be in the future available on a public domain. That's a typical code list that can be used in Flanders. In the next slide, you can see how we've modeled the external links to get more information on the POI. And the next slide, it's yeah, here we have the contact information with one specific role here. In this case, it's the author. This is the one that is responsible for the information or the address information of the hotel in this case. And on the next slide, there you can see how the metadata information and the license information is modeled. The metadata is a reference to a geo catalog, and the constraints that the license that we use here in Flanders, which is sort of open data license. And in the next slide, you can see that it has coordinate information to show the location of the POI. And then there's one extra attribute, a POI, a property that has been added, and that's the address information, because this address information is a simplified version of how we model addresses in Flanders. So this one is here specific for our use case. So this is what I have done, and this is my use case. And if there are any questions, they're welcome.
Thank you, Koen. I'd like to go ahead and, if you have questions, put them in the chat, and then I'd like to ask Howard to present about your use case. Maybe introduce yourself as Koen did first.
Yes, so I'm Howard. I'm work at Google, and I'm responsible there for most of the data about POIs that we use in maps and search. And we would like to be able to interchange this data. I mean, mostly we're interested in acquiring data, buying it perhaps from providers who have maybe specialized lists of data. So this is very similar to Koen's use case. I think, you know, our end use is a little different, and also our relationship with the providers is a little more arm's length. Next slide. Yeah, so the use case is, you know, these search applications like Google want to be able to search and explore and navigate to POIs. And there is a market that exists for buying and selling such lists of such places. And it would be great if there were a standard interchange format. Google defines its own proprietary XML format. It would be much nicer if there were an OGC format that everybody knew about and worked with. Really, when we think about POIs, we're thinking about these main things that are at the bottom. We need a name for the place, a latitude, longitude, an address, a phone number, a category, the business hours, and the website. Not all of those will always exist, but when they do, we would like that information. Next slide. So here's an example POI. This is a quick stop store, and it's in a city in Minnesota. I just made this place up. This isn't real. And it has all the information that I told you we need. And then on the right, I'm showing you how we can encode it using the standard that we're talking about here today. So at the very beginning of the standard of the encoding, we'll say, all right, this list of things is a feature collection, and here's some of the features in it. This is one of the features, Bob's Quick Stop. It has the required feature ID and optional names and contact info. It has a required feature of interest, but in this particular application, the provider is so arm's length from the user of the data that the provider may want to keep that opaque and hidden. And so I've had to put an empty feature of interest here. Next slide. For address, this isn't a mandatory or normative thing that is in our standard right now, but there is from the city GML some information like CI address, similarly for telephone and online resource, that are suitable for giving the address and a phone number and a website. And so I've encoded those this way. As I say, these are not normative, so this would be something where you can put it in the file and it validates against our current schema, but it is a suggestion rather than something that is in the standard. And we're interested in feedback, whether just saying here's a best practice, encode it this way, or whether there's an appetite to have this more formally written into the standard. Next slide. One of the hardest ones to deal with is hours of service, because this is not in any of the standards that we were looking at or importing right now, certainly not in the city GML one. And asking around, we found that the best possibility was this calendar availability that the vCard RFC talks about, with a availability extra addition to that, and there's another standard for that. This gives enough flexibility to represent everything you want to know about business hours, both how they go week by week, how they have special holidays, how they may be seasonal. All of those things are expressible here. The really only big downside of this is it's a pretty hard to read and dense representation of that information. But presumably there are pieces of software that already know how to read this standard and can be used for processing this data. Next. And then finally, this is another place where there's a bit of a difficulty, is the category. So internal to Google, we have about 5,000 categories that we can use on businesses, and there is no comprehensive list anywhere near that big that is public. One possibility would be this NAICS, North American Industry Classification System. It has, a reasonable top level categorization of businesses, but it doesn't go nearly as deep as certainly our users would like, and I think some of our providers would have. So, another possible question for the group today is there an appetite for us to try to standardize a larger categorization set, or is this NAICS thing sufficient? Next slide. That was the end of me. Thank you. Any questions, I guess, go in the chat and we can answer them at the end.
Yeah, thank you. Yes, we have one more presentation. Kyung-Soo Kim, if you are available, could you unmute yourself and join us?
Okay, thank you. So I'm Kyung-Soo Kim, a researcher of IST in Japan, and I'm also the co-chairs of the OGC Moving Pictures Week and GeoAI Week. And these use cases, I think, are a little bit different from the typical POI use cases. So considering the static location of the POI, its use cases, we are considering more dynamic properties. So motivation is that, such as for the finding the ride services, the passenger wants to find the ride share from the starting point to the destinations. And in these cases, we have this some requirement, such as searching the services in the request area, and also filter services with options such as the price, type of ride, or drive evaluation extra. And then we want to send the request to the user want to send the request to selected driver and monitor the location and arrival time to take a ride, and also monitor the travel location during the trip. And then finally, after the trip, and they want to evaluate it. Next slide. So in this case, so ride service is we can also consider about a POI, but this is assigned of the one of the moving feature that has the dynamic properties. What is the dynamic properties? It means the property value is changing over time. So for example, locations and validated times and driver evaluations, price, speed, and number of passengers. This kind of a POI properties has the dynamic value depending on the time. So currently, I think the current conceptual model of the POI, I think it's cannot be covered of this kind of lighting services, but this is not only for POI problems. I think because of the conceptual schema of the application schema of the ISO 19109, and then also ISO 19141, the moving feature schema, those standard is not enough to represent it of this kind of features. That's why I think in these times we cannot if we want to cover this kind of object as a POI, I think we need to consider about some other standard data. Okay, thank you.
All right, that's perfect. Timing, everyone, thank you. That was really, really good, really clear and concise. And I think those 3 use cases illustrate very, very well how this POI model is working, and is also the questions that we as a SWIG have and would like to answer with your help. So I wonder if there's anybody who'd like to start the conversation, or if Chuck might have had a chance to look at the OS POI product and the link that Stefano provided, maybe make a comment about that and help break that nut open.
Sure. Maybe I can go first, guys. So Stefano, principal scientist at Ordnance Survey. One of the things that was not really mentioned in the last 3 use cases is that POI, so at least that's how Ordnance Survey is interpreting a POI, is a specific point location that really someone finds useful. Not all of those have an address. Not all of them are in urban environments. There might be, features or landmarks in the natural world as well, especially I'm thinking some of the customers that we have in the kind of trekking, walking community. Some of those features are POIs, but there's no way that, you can get a specific address to associate to them. And even location can be quite a challenge to define where exactly, you can identify the point. Is it the centroid of a polygon that represents a woodland or a specific, viewpoint? It gets, messy quite quickly. So what we tend to do at Ordnance Survey, we have this concept that might be helpful for the community. I don't know, I'm just putting it out there, of positional accuracy. And we have a code list of 4 categories to capture exactly that. So is this something that we can address with a lat and long? And we are confident that that's the location of this POI. Do we want to have a bit more of a vague position in terms of a centroid of a specific road, position within a building, or in the locality, of a neighborhood or another, geographic area that we can define in some way? So I thought I would share that with the community. But very interesting work. And if I have the time, I would be very interested in trying to implement some POIs from Ordnance Survey with this UML model to test it.
Stefano, if you have time, you would also warmly invited to attend our SWIG meetings. I can add you to the invitation. Thank you.
1016.
I just
Thank
wanted to
you.
respond a little bit to that.
Yes, absolutely.
Stefano, I think that is a very good point. Internally at Google, we also have a concept of the positional accuracy of POIs. It is important. Unfortunately, we don't often have a good idea what that accuracy is. So I think that yours is a good suggestion. If providers have this information, it's something that would be well to model.
Chuck, do you have anything you want to add?
My only observation, my only observation is that positional accuracy, do we have agreement on how it should be represented on the POI? I mean, clearly I would use a covariance matrix, but nobody's going to understand a covariance matrix. So we need something a little bit more human accessible. So suggestions and recommendations
Potentially,
are
Chuck, we could leave it open to check. Potentially the positional accuracy could be kept open. It could refer to a specific data set. So in our case, to be the Ordinance Survey POIs will have his own positional accuracy code list that you could refer to. Maybe Google will have their own one, or others will have other concept of positional accuracy. I don't know if that makes it too complex to actually allow that, but that could be a solution.
Okay, so essentially the positional accuracy is derived from the positional accuracy contained in the data set. And if the data set does not carry positional accuracy information, then well, you could still populate it if you have. All right, if you have collection criteria for the data, I'm free just rambling now. But if you have policies and quality controls on the data that's collected, then you would have that positional accuracy even if it's not represented in the data set itself, correct? No one's saying no, okay. So we'll have to play with that. It will be kind of tricky to come up with an approach that is actually meaningful and still flexible enough to handle everything, but yeah, definitely we'll have to add that to the list.
Thanks. Reese also says that CalConnect is working on the VCARD data model, so that could be interesting for the time and date when that comes along. And Timo, did you want to? Timo, you've been participating regularly in our SWIG work, so please introduce yourself and share with us this feature of interest.
Right. So hi everyone, and sorry about not being so active in the past months, but yeah, in the beginning, yes. So I was just thinking also after the moving features presentation that the feature of interest is actually quite powerful thing that you can then create the relation between the point of interest and an actual feature there, and then the feature could have the positional accuracy and it could have the elements that are needed for routing and everything else, so that we can keep the point of interest as like abstraction of the actual features. And there has been an additional need for this, because one of the things that we have been finding out when we have been moving on these like pilot and experimental things is that it's actually not so easy to find out the explicit reference to GML ID or WFS ID, because there are several instances of both. That we have at least 2 different city GML models where our buildings currently are, maybe even more. So it is good to also keep this kind of level of federation or level of abstraction in order to make sure that we can maintain the points of interest as one catalog, and then the geospatial infrastructure as the other one. That is, there could be links, but it is not necessary.
Any comments? Feedback to that suggestion? All quiet. Well, this has been very valuable, and I appreciate everybody's time for attending this edition of this briefing. And I look forward to hearing the outcomes of the next briefing in a few hours, in 10 hours or thereabouts, maybe 8 hours. And thank you all, those who presented and prepared for this briefing. And thank you to Greg for setting it up and giving us this opportunity to engage further. So with that, I'll be happy to close. Did somebody take a breath?
Check. Might mention where the transcript and recording of this session will be posted.
I'll put it in the SWIG folder.
Yeah, we have a folder
Okay.
for this particular briefing, and I believe if we if you do look at that folder, you could make this these slides public so that anybody can access them. If that certainly is our goal, is to make the slides public.
Got it.
So
Okay.
thank you, Greg.
Can do.
All right.
Christine, quick question.
Yes, Reese.
Reese? Yes. So if I understood things correctly there, and so the POI will support point geometry, line, string, and a polygon. Is that the idea now?
Yes.
And so will it still be called the point of interest, even though it supports these other types of things?
That's my understanding. I think it's such a widely understood and widely used term that it would be confusing to change it. But does anybody else have any comments or opinions on that?
But do people expect a point and a polygon is returned, or I'm sorry, I'm not implementing anything there. I'm just, listening to the presentation.
So we've kicked this question around quite a bit, and what we get back to is the POI is a brand, really. It's a widely recognized term, and yes, what we're returning may not necessarily be a point. It could be more complex, but to change the name at this point would just cause confusion in the marketplace. Let's put it that way. So I think it's what's commonly used, and we're stuck with it.
What does the ITS domain think about this? Intelligent Transport, TC204. They are following these?
Not to my knowledge, but Reese, if you could introduce us, do you know people at TC204? Because we could, or maybe Greg, and we could
yes, I
make them aware of our work, and maybe
I think Kim-san's here today, so
yes,
she's with TC204, so yes.
Well, I think, one of the things I found, and I appreciate you bringing this up, is that there's a core group of people, as in most standards work, that invest more heavily, and then there's a lot of people who are at a distance. And in this case, we're at this critical stage where we need to get out and validate, and that's the purpose of this briefing. And so having these suggestions is really, really good. We brainstormed a bit before on who we would like to have participate, but I think reaching out further is it's our responsibility to do that at this stage. So thank you for bringing that up.
Yeah, no. I enjoyed the presentation. Thank you, Chuck, Christine, everybody. Yeah, very interesting. So very interesting.
Thank you all. It's the end of our time. Look forward to the continued conversation. Bye.
Bye, everybody.
Thank
Thanks.
you. Bye.
Bye.